Okay, so like everything in this chapter, dot structures are critical. So got a little bit extra space down here because we're going to need it. So I'm going to start there with A. And so with A, you should have done something like this. And then add your dots. And then check your target number. So the target number on this boron and fluorine. So you have one boron, and that's going to give me 3 electrons. And then the fluorines are 7, and there's 3 of them. So then that's going to be 21. So my target number here is 24. All right. So let's look at what we've got here: 2, 4, 6, 8. 10, 12, 14, 16, 18, 20, 22, 24, 26. So we actually have 26 and we need 24. So we don't quite have what we need. So we're going to go ahead and add a double bond. Doesn't matter where. I'm going to just put it right here. And then take away a pair of electrons from each side of that bond, like so. And then there's your structure. And so that's going to be AX3, which is trigonal planar. So that one, A, right here, that's going to be non-polar. So not polar because look, there's no electrons in the middle, no lone pairs, and then all of these are fluorines. So that's a no for different X's, and it's a no for dots in the middle. So no and a no, non-polar. So that's going to be for A. All right, so let's take a look at B, which is SO2. So this is going to get a little messy because I'm going to have to find spaces for all these. So here we go. Okay, so we need a target number. So let's just do the target number real quick. We've got sulfur and oxygen. So sulfur is 6 and oxygen is also 6. So it'd be like 6 and then 2 is 12. So target number is 18. So if you count this 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, then that's too many. So we're going to have to make a double bond somewhere to go down. So I'll just make it here. And then I'll just get rid of a set of electrons on each side. So now if you count it again, you're going to get 18. So 18 is going to work. So that works now. So that's going to be an AX2E1, right? Because that's an E1. Now that right there, that E1 is going to make it polar. So this is going to be an AX2E1, which is bent. And so B is going to be polar. Okay, why is it polar? Because it has these dots in the middle. What does the polar idea mean? It means it's not a symmetrical shape. It's bent, so it has legs basically. So let's do this BRCL. Okay, I'll tell you right now that this one you don't even really have to draw, but you can look at that right away. So I can look at this right away without even adding any dots, and I can tell that this end and this end are not the same. So since they're not the same, it has to be polar. One of those ends has to win the tug of war. So this is a linear shape. It doesn't fit a lot of our plans because it's doesn't really have a central atom. But right away, I can tell that this one is going to be polar. And that's because the ends are not the same. So either bromine or chlorine has to win the tug of war. Now, if it was just 2 bromines, or I guess we can just do the next example. Look at the next example. Also don't have to do a lot of work because the next example is two identical atoms. So this is going to look equal on all sides. Now we can go ahead and do the dot structure, but it's not going to change anything. This is going to look the same on all sides. Target number on this one is 10 because they're both 5s. This is 14. So what you're going to end up doing is you're going to go, okay, get rid of those, add another one, get the triple bond, get rid of those. Now it's going to be 10, 2, 4, 6, 8, 10. So that's the correct structure, but I didn't really have to draw it because I can look at those two nitrogens, which are identical. I know that the shape is symmetrical. It has no dots on the central atom because it doesn't have a central atom, so I can't even use that rule. So this one right here is going to be not polar, non-polar. Now you could dot this one up too. It's not going to matter. It's going to get you the same result. So that's just kind of why I skipped it. So don't worry about that. You should be able to visually figure that one out. Okay, SO3. Okay, SO3. Let's do that one. So S in the middle, and then you got these O's. Let's go ahead and dot it up. Okay, so we need to get a target number. So they're all 6s. So you got like the 6 for the sulfur, and the oxygen are also 6. There's 3 of them, so that's 18. So we're going to have 24. So if you count this, 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 4, 26. Going to have to go backwards a bit because I got 26 and I need 24. So we've done this before. Drop in a double bond. Go ahead and wipe out some electrons. And that's going to be 24. So what is that? That is an AX3E0. Just like A. So just like A, this is going to be non-polar. Right? So that one is going to be non-polar. Why is it non-polar? It has no dots in the middle, and it doesn't have different elements. These are all oxygen, so it's going to be symmetrical. Now, one thing to understand is that I kind of draw it like that, but it is symmetrical. So if I go back to here and I take a look, see, it ends up looking like that. And so even though I draw it like in a T shape just to make it easy to draw, they do spread out and become a symmetrical molecule. Okay, SO2Cl2. So what's going on here? And you don't have to do a lot with this one either. Sulfur's in the middle. Then you got the O's and the Cl's. Now, I don't have to do anything else because the rule tells me if the X's are not all the same element, it's automatically polar. So since those are different, this is automatically polar. And that's because these are not the same. So the chlorines and the oxygens are going to fight for the electrons, and they're going to either go to the chlorines or the oxygens. Now, you can go ahead and finish out the shape if you want, but it's going to be polar, and you don't need to do more than that because you can tell that the X's are not the same. And that goes back to that rule right here. This first one, attached atoms are different. Yes, the attached atoms are different. They are O's and they are Cl's. Okay, let's do the, kind of run out of space. I'll probably do that G down here. So I'm going to do it down here at the bottom. So I've got chlorine in the middle, and then some fluorines attached. And then let's dot them up. Hopefully by now you're getting pretty good at this pattern. This is the most important skill in this unit because the if you can't do this, you can't do anything. So that's like super important. So let's count them up. Oh, sorry, we need a target number. They're all sevens. Chlorine's a 7, and then 3 sevens for fluorine, 21. So 28. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So we've got 26. Remember, everything counts as 2. So that's not enough. So we got to add some dots. Where are we going to add them? We add them right here in the middle. And so now we have 28. So what is this? This is an AX3E2. So if you look at that, right away there's dots in the middle. It's not symmetrical. It's a T-shaped molecule. And so because it's T-shaped, so it has ends, and because it has dots in the middle, it's automatically going to be polar. So this one is also polar. And then running out of space, so we'll do the BRF5 over here. So bromine in the middle. Oh, go with a different pen color. Here we go. Bromine in the middle. And 5 fluorines. So we got like 1, 2, 3, 4, and 5. And then we can dot them all up. No dots on bromine. I mean, it already has 5 attachments where it really normally should only get 4. So already we got some expanded octet squirreliness going on here. So we'll add all these dots. And then we got to get a target number. Well, every one of these is going to be a 7. Again, they're all in column 7. So bromine's a 7. And then you got 1, 2, 3, 4, 5 more 7s. So we're going to end up with 42 as our target number. So count it up. 2, 4, 6, 8. And I'll give you a bit of a hint. See how they're all the same? That's going to be 1, 2, 3, 4, 5. So that's going to be 8. Times 5, which is 40, which is not going to be enough, but I'll count it for you. I'll show you again, but you can kind of get a pattern. They're always 8s on the ends. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. So just like I said, it's 40. Sometimes I make a mistake because I forget to count 1, but there's 40, and I need 42. So I'm going to go ahead and erase all my circles. Can't do that with a pencil, which is why the pen's kind of nice. But I got to add some dots in the middle to get to 42. So see, those dots in the middle made it polar. If I didn't have those dots in the middle, it would be nonpolar because it would be 100% symmetrical, no dots in the middle. These are all the same element. But since I had to add that pair of dots in the middle, it suddenly becomes polar. So now it's an AX5E1, and that E right there, that made all the difference, which created a polar molecule. So kind of get the idea on polar, nonpolar, and hopefully you're getting it figured out how to draw these structures. So this is actually the end of a section. Lots and lots of notes. Always takes forever on this, but very important to be able to do these dot structures because that's really the heart of this whole unit. So all right, I'm going to pause it here, and we'll start the next section on the next set of notes.